Okay, this is sequence and series review 2. There are 9 questions and it should not take long. Okay, if a sine wave's amplitude divides by 3 after every cycle, then after how many cycles will it become 1 upon 243 of its original amplitude? So this sine wave or anything else, amplitude, uh, these phrases are just distractions. You can start with 1, yeah, or 1x, 2x, something like that, yeah. So start with 1 or any multiple of 3 that you can break it down, yeah. I'll start with 1. So after the first cycle, yeah, it becomes 1/3. After the second cycle, it's dividing by 3 after every cycle, so 1/9. After the third cycle, it becomes 1 by 27. Fourth cycle, it becomes, after the fourth cycle, it becomes 1 by 81. And after the fifth cycle, it becomes 1 by 243. And so the answer is after how many cycles? So it's after 5 cycles. After 5 cycles. That's the answer. Okay. The product of first 3 terms of a geometric progression is 4096. If we subtract 6 from the second term and divide the third term by 4, then the 3 terms form an arithmetic progression. Find the terms of the geometric progression. So just a reminder, geometric progression is when there's a constant ratio between any 2 successive terms, like a multiplier. Yeah, like in the previous one, the multiplier was 1/3, 1/3. So that was the geometric progression. And arithmetic progression, there's a constant difference between any 2 successive terms. So there's either an addition of a constant happening or there's a subtraction of a constant happening. So now, um, one way to solve this quickly is to guess your numbers. Yeah. So what I see out here is that the product of the first 3 terms of a geometric progression is 4096. Now, if I remember, 2 to the power 10 is 1024. 2 to the power 11 is 2048. And 2 to the power 12 is 4096. Yeah. So it keeps doubling. So if I were to talk about 3 terms that's multiplying to 4096, then obviously it's not going to be 2, 4, and 8. Yeah, because it's a very small number, 64. 2 fours are 8, 8 8 is 64. All right. So then we might think that what other numbers that you could work with to give you 1024. So then we break down, okay, 2 to the power 10, yeah, or what other numbers would break down to 2 to the power 12? So 2 to the power 12 can be 2 squared to the power 6. Yeah. So in a way, I can say it's 4 to the power 6. Right. Okay. So then that's how you take a guess that maybe it will be a multiple of 2. So what if it's 4 times 4, 16 times 4, 64? Yeah. And if I am multiplying them, then this is 4 to the power 1, 4 square, and 4 to the power 3. And 3 plus 2 plus 1 is 4 to the power 6. So that's one way to get to your answer, that if I multiply them, it gives me 4096. Yeah. You add up the powers basically to represent 4 to the power 6. Okay. Now, if I write them down in this fashion and then I check the second sentence, if I subtract 6 from the second term, I get 10 and divide the third term by 4. So I get a 16. So 4 plus 6 is 10. 10 plus 6 is 16. So I've got a sequence in AP where there's a constant difference of 6. So therefore, the 3 terms which are in the geometric progression is 4, 10, and 4, 4, 16, and 24. That's my answer. Now that was, if you're good with numbers, you could do that. But then let's say if you have to really sit down and do the math on this, then you would probably say, okay, let the first term be x, let the ratio be b, and then it'll be b into x, and the third term would be b into b into x. So that when multiplied gives you 4096. And if I subtract 6 from the second term, yeah, remember x is my first term. So x into this b is the ratio, so multiplier. And then the third term is bx into b again. Okay. And if I divide b square x by 4, yeah, then these three terms are in a AP, arithmetic progression. So just to give you an idea, suppose if it's 2, 4, and 6, and if the sequence is in AP, 2 plus 2, 4, 4 plus 2, 6, then I know that 6 minus 4 will be equal to 4 minus 2. So that's what we're going to do out here. Yeah. We're going to say b square x upon 4 minus bx minus 6 in bracket, don't forget the bracket, is equal to bx minus 6 minus x. Got it? That's one relationship that we can work with. And the other relationship is this one, that is x into bx into b square x is x cube into b cube. That is 4096. So then we can write down x into b the whole cube is 4096. Therefore, we can say x into b is equal to 4096 raised to 1/3. And we know that 4096 is 2 to the power 12. Yeah. So therefore, x into b is 2 to the power 4, because 12 by 3 is 4. Yeah. We multiply 12 into 1/3. So that's exponents you got to know at your master's level. Okay. So x into b is equal to 16. So that's one thing we got. Yeah. And we will simplify this one. When we simplify this one, we get, first of all, we'll multiply 4 throughout. Yeah. So to get rid of this denominator. So b square x minus 4 times bx minus 6, yeah, is equal to 4 times the whole thing, bx minus 6 minus x, because we're multiplying 4 throughout to get rid of the denominator. So b square x minus 4bx plus 24 is equal to 4bx minus 24 minus 4x. And we simplify this, so we get b square x, and then this 4bx and this 4bx becomes minus 8bx, and this 24 and this 24 becomes negative 40, positive 48, and this negative 4x comes and becomes on the other side and becomes positive 4x. 48 is equal to 0. Now we'll plug in the value of bx in here. Yeah. Sorry, not the last one, in these two. So this is b into bx. Yeah. So b into bx, we can write it down as b into 16 minus 8 into 16 plus 4x plus 48 is equal to 0. So therefore, I'm going to continue working it out here. I got x and b equation. So we can say that 16b minus plus 4x, and then we got plus 48 and minus 8 into 16. So what is 8 into 16? 16 tens are 160, subtract 32, so 128 is equal to 0. Simplify this further. Now, we know that we can't solve it with simply b and x, right? We need to have a singular linear equation. So what we can do is we can say that let b be equal to 16 upon x, right? Yeah, from here. So then 16 into b, which is 16 upon x, plus 4x, and minus 48 and minus 128 is 80. Yeah, minus 80 is equal to 0. Now we'll subtract throughout by x. So we get 256 plus 4x squared minus 80x. Now we know that all of these are multiples of 4. So we'll divide by 4. So 64 we get here. We get x squared here, and we get 20x here. And when you solve this quadratic equation, yeah, remember quadratic equation, x squared minus 20x plus 64 equal to 0 gives you 16 and 4 minus and minus. And so my value of x is either 4 or x is equal to 16. So we already know that when we worked it out quickly, yeah, we got 4 as x, yeah. And if x is 4, then b is 4. So my b is 4. So 4 into 4 is 16. And then 4 fours are 16 and 4. So basically, this is what we get. And these are my three terms. Now you might try out, what if x was 16? If x was 16, yeah, then b would be 1. And that would not be in geometric progression. Yeah, it would be 16 and 16 because b is 1, x is 16, 16, 16 you would have got. Yeah, b is, like, if x was 16, then b is 1, 1, 1. So you would have got 16, 16, 16. Yeah. So is 16, 16, 16 in geometric progression? Then you'll have to work out the second sentence. What if I subtract 6 from here? I get 10. What if I divide this by 4? Yeah, so I get 4. So 16, 10, 4, it works out. 16, 10, 4, yeah, it is in AP. And 16, 16, 16 also works out. Yeah, but what we are really looking at is, are we looking at 16, 16, 16 as geometric progression, or are we looking at, 4, 16, and 64? Because both of them gives me an AP sequence, 16, 10, 4 in one, and 4, 10, 16 in the other. So you got to decide, find the terms of the geometric progression. Now, normally there'll be answer options. So you can either go with 16, 16, 16 or 4, 16, 64. Ideally, it would be 4, 16, 64. But if they do have 16, 16, 16, not a problem. Now, if they do have answer options, then the problem becomes very simple. You don't have to work it out the way I've worked it out. Yeah. You can just simply use the strategy of plugging in the answer choices to get to your answer. Meaning, whatever answers you have, yeah, you probably have three numbers, so you can just simply multiply those three numbers, see if you're getting a product of 4096, and see when you use the second sentence, subtracting 6 from the second term and dividing by 4 from the third term, whether you're getting a geometric progression. I'm sorry, an arithmetic progression. So that's with the second question, pretty long, but it was worth it. Third question, which term of the GP, geometric progression, is 3, 1, 2, 5? So that's very simple. You already got the sequence in front of you. And we know the multiplier is 5, that the ratio is 5. So which term of the sequence? So it will be the fifth term. First, second, third, fourth, and this is the fifth term. Yeah. Beginning from the third term, every term in the sequence, 6 minus 4 minus 24, 96, is the product of the preceding two terms, beginning from the third term. Yeah. So what is the sixth term? So this is my fourth term. 96 into negative 24. 4 6 are 24. 4 9 are 36, 38. 0, 2, 6 are 12, 2, 9 are 18 and 19. So I got 4 and then 13, 2, 3, 0, 4 as my fifth term. Yeah, negative obviously, because it's the product of these two according to the statement out here. And then again, the sixth term. So I want my sixth term would be the product of these two numbers. So it'll be 2304 into 96. Yeah. So that's 6 4 the 24, 2, 18, 13, 0, 36, 3, 27, and 20. So 4, 8, 11, 11, 2, 2. 221184 is my sixth term. Simple multiplication, you can solve it within 3 minutes if you're slow with your calculation, or else in 2 minutes. Yes. So like I said, they don't really ask questions, where you have to apply a formula. It's just logic. Yeah. If a bacteria divides itself into 30 more bacteria every minute, then what is the total population of bacteria after 5 minutes? The population of bacteria at 0 minutes was 5. So it says clearly out here, if a bacteria, meaning one bacteria, divides itself into 30 more bacteria every minute, yeah, then what is the total population? So let's just talk about one bacteria. Yeah, it's after 1 minute, it divides into 30 more. Yes. Then after the second minute, after 2 minutes, it divides into 30 into 30. Yeah. Yes. 30 square. After 3 minutes, it becomes 30 into 30 into 30. Yeah. 30 cube. All right. After 4 minutes, it is 30 to the power 4. And after 5 minutes, it is 30 to the power 5. Interesting. So that is happening with one bacteria. Now, at 0 minutes, the population was 5. So you have to repeat that for second one, third one, fourth one, fifth one, and then add them all up. Correct? Yes. So basically, this is my answer for one of them. So when I add them all up, it will be plus 30, plus 30, plus 30, plus 30. Therefore, it is 5 times 30 to the power 5. So 5 times 3 into 10 to the power 5, correct? Yes? Yes. 5 times 3 into 10 to the power 5, that is 15 into 10 to the power 5. Right. Okay. No, my bad. My bad. It is 30 to the power 5, so 3 to the power 5 as well. So this one breaks down as 3 into 10, like this. Correct? So it becomes 3 to 5, 10 to the 5. So 3 to the 5 is how much? So we know 3 to the 4 is 81. So 3 to 5 is 243. So 5 into 243 into 10 to the power 5. Right. One silly error. And even after knowing how to solve the question, you would mess it up. So be careful with your calculations, right? So 5 times 200 is 1000. And 5 times 43 is 45, that 200, 215. Add them up. So that is 1215 into 10 to the power 5 will be the total population after 5 minutes, when the 0 minutes population is 5. Okay. So we move on to question number 6. A tower clock, giant bell clock, rings once every 3 hours in a day. How many times would the tower clock ring from the 28th of June, 3 p.m., yeah, to the 3rd of July at 6 p.m. So June has 30 days, not 31 days. And July has 31 days, but they're not asking up to 31, but just a third. Okay. So when you say, let's just say that 12 a.m., yeah, 3 a.m. in the night, 6 a.m. in the morning, 9 a.m. in the morning, 12 p.m. afternoon, that is midday, 3 p.m., 6 p.m., 9 p.m., and then again 12 a.m. So there are 1, 2, 3, 4, 5, 6, 7, 8 slots available. So on the 28th, it begins at 3 p.m. So strike 1, strike 2, and 3. And this one has 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And July 3rd of July at 6 p.m. So 1, 2, 3, 4, 5, 6, 7. So you got 3 here, 8 here, 8 here, 8 here, 8 here, 7 here. That's 32 and 10. Yeah, 10. That's 42 times it rings. So it rings once every 3 hours. So these are the timings. Yeah, right, for this one. So let's move on to question number 7. Okay. A cat gives birth to a litter of 6 kittens every 4 months. If a cat continues procreating for 8 years from the beginning of 2011 to the end of 2018, then how many kittens she has given birth to from January of 2015 to December of 2017. So 2015, all the 12 months, 2016, all the 12 months, and 2017, all the 12 months. Assuming all kittens were born healthy and in a litter of 6. So uh, the cat gives birth to a litter of 6 kittens every 4 months. So Jan to April, yeah, we have 6. Okay. Then May, June, July, August, we have 6. And then September, October, November, December, we have 6. So that is 18 per year for all the 3 years. And that makes it 54. So question is how many kittens she has given birth to in 15, 16, 17. That's 54. That's it. Question 8. If a climbing rope is printed with solid colors, red, blue, green, yellow, purple, in that order, equally spaced, where the sequence is repeated every 1 meter. So 1 meter is 1,000 centimeters. No, 100 centimeters. So 20, 20, 20, 20, 20, correct? So the question is find the color at the end of 4,600 centimeters. Okay. So 4,600 centimeters is 46 meters. Okay. Right. Right. So therefore, in this case, the answer will be find the color at the end of 4,600 centimeters, and that'll be purple. Yeah, because it's after every, it repeats after every 1 meter. So Again, the red comes up here. Yeah. And then the sequence repeats: red, blue, green, yellow, purple. So the end of 4600, yeah, or 46 meters, in other words, would be purple. So purple's your answer. Right. Question number 9. Find the 18th term of the sequence of all terms in the sequence and the sum. So find the 18th term and the sum of all terms in the sequence given to you up to the 18th term. So sequence is 9 minus 8, 7 minus 6, and then repeats again 9 minus 8, 7 minus 6. Right, that minus 6 out there. So up to the 18th term. So maybe I need to get this bracketed portion in the second line out here, so that that minus 6 doesn't confuse, but it is minus 6. So therefore, I have so far 12 and then 16 and then it stops here. So my 18th term is minus 8. Yeah. And the sum is 9 and 7 is 16. Yeah. And minus 8 and minus 6 is minus 14. So I have 2, 2, 2, 2, 8, 8, and then adding these two. Yeah. So 8, 9, and then minus 8. So my sum is 9 up to the 18th term. That's a sum. Easy peasy. Okay. Next question. That's it. 9 questions only. So this was fast. I mean, it didn't take much time to complete the remaining 3 questions. So that's it for sequence and series. My next topic would be data interpretation and logic, and that would be the end of part A questions. I've pretty much covered most of the topics, yeah, in part A. Maybe ratios, percentages is what I would like to add. So yeah, maybe one more topic that would cover part A. So we'll move on to data interpretation and logic, and then we'll probably discuss ratios and percentages if possible. Yeah. And thank you.